All right, next up we have Gigalo Networks from UC San Diego.
All right. Hello, I'm Alan Benjamin, the CEO and co-founder at Gigalo Networks, where we are looking to fundamentally rewrite the rules in the data center. All right, so think deep inside the data center, those buildings that you probably drive by all the time and never really think about, but where most everything from your cell phone or from your laptop or computer ends up. And what's happening, before we talk about what we do, let's talk about why what we do is important, because the data centers themselves are undergoing a fundamental and revolutionary change brought on by a massive growth in data. And everybody that you'll hear today, people will talk about AI and people will talk about deep learning and various forms of new high performance computing, and it is putting an enormous strain on the data center itself. So some of you may be familiar with this chart, which came out from IDC and Google back in 2013, and they picked this chart because they said it was a seminal moment in human history. That in 2013 that we were going to create, and they gave the number, but the number's not really important, they said that will be equivalent to all data that has been created by mankind up until that time. And so effectively in 2013, mankind was going to double its amount of data. And then they went on to talk about, they gave a forecast by 2020 that this was going to be, it was going to grow over tenfold. Now, last year they updated their numbers, and they said in 2016 there had been about a 4x growth in the amount of data. And so we're well on track to hit their forecast for 2020, and they updated and they gave a forecast for 2025 and showed, once again, an enormous amount of data that's coming. And so when you have this sort of data, it is forcing a fundamental change inside of the data centers. So when you talk about data, we'll just go for very quickly a very, very simplified model of what people do. What do they do with the data? Well, you collect it, you process it, you have to derive some sort of meaning from it, and then you store it away. Right? So regulators, auditors, and other people can get to that data at some point in time when they need. So there's a number of changes in the data center. I'm going to pick out a handful that matter to us in particular. First, the processing capability and the storage capability that is happening in the data center has gone through enormous growth. All right, CPUs have grown in power up to 100 times, and more importantly, people are now changing the compute model and are moving to GPUs. And for those of you fortunate enough to have bought NVIDIA stock a handful of years ago, back when there was that little circle of data, you know what I'm talking about, right? So the compute model is changing, and the storage now is also radically improved in performance, right? With moving from rotating drives to solid state drives, and then new controller technology called NVMe. Maybe because of that, or maybe in spite of that, we now have this whole new domain expertise called artificial intelligence. And so you now get vast amounts of data that are capable of being processed, and in the flip, you have to have AI in order to process all the data. And third, as data has now grown even larger, companies are looking at fundamentally redoing their architectures and starting to move some of this processing capability out to what's called the edge. So they want to do some pre-processing where they're collecting the data so they don't have to send as much of it across the networks, right? Which they have discovered is extremely expensive. Now, if you're thinking right about now, well, hold on. You talked about a lot of change, but isn't the very simple pipes over which all of this data going, isn't that becoming a bottleneck? Isn't that becoming the problem? And in fact, it is. And so in a survey done last year of people who manage and architect these sorts of data centers, they asked them what their biggest problems are. And as you can see from the chart, 91% of them said their single biggest problem today is the performance of their interconnects, that they are simply too slow, they're too rigid, and they're too expensive. So they don't come close to meeting their needs, but it's what they've got. This is the problem we fix. So one definition before we start, people call some of these computational clusters different things, stamp cells, pods, whatever. And for the purpose of our presentation, we're going to call it a cluster. And a cluster could be a half of a rack, it could be a full rack, it could be an entire row. So it's just some grouping of computers that are necessary to be working together. The market is, this is the market for networking within the data center, right, over in the blue. $15.5 billion will be spent this year. The types of systems that we're concentrating on are about 40% of that. By far the fastest growing segment because it's being driven by AI and deep learning. So it's a little over $6 billion today. We talked about the movement to the edge as people re-architect their systems. This year, that will add another $2 billion. So we're looking at about an $8 billion market this year, growing in the 15 to 20% range. So it's important, you say, okay, what is it that you do? How do you alleviate this? Well, more important than what we do, it's what we don't do. Now, if you're communicating from server number 1 to server number 2, right? Important to know inside that server, the language that those processors, and it doesn't matter whether they're Intel processors or AMD or ARM or IBM, because they all speak the same. The output, the native language that they talk is called PCI Express. And inside that server, every server on the planet is architected around PCI Express. And if you're going across a network today, you then you translate into Ethernet, or you translate into InfiniBand, you go into the second server where you immediately convert it back to PCI Express. And very simply, we just don't do that. The guys who invented our technology figured out how to move the data at the PCI Express level, how to create a fabric out of PCI Express. And it sounds so simple when you hear it. Now, there's two major benefits that we get from doing it. Number one, we go faster. And here's the actual numbers. But let's talk about a figure of merit we all know, the blink of an eye. So in the blink of an eye, state-of-the-art Ethernet system today will transmit from one to the other 5 messages in the blink of an eye. InfiniBand, which is gaining in these high-performance systems, will transmit 25 messages, and that's fundamentally why they've been gaining ground. In the blink of an eye, because we don't do any of those translations, we will send 500 messages across that fabric. But it's not just performance. You saw that we fundamentally, we interact at a different point in the stack. And so literally, in all senses of the word, that rack becomes one system. So it no longer matters where you plug in a CPU or an FPGA or more storage. It doesn't matter because they become cluster resources. We have a great patent position. We have 6 issued patents. We have more coming. And it covers the very specific of what we do to the very broad concept of what we do. The technology is great, but the team behind this, because one of the questions that you get, building a high-performance network and a high-performance fabric is hard. And the team has done this. Every one of us who are in the company have been in the communications business for decades. The go-to-market team, of which one of the guys is back here, right? The go-to-market team has done this. Our head of sales was the guy who ran sales for our largest competitor. All right? Our marketing guy did this at Sun Microsystems, and our technical team have built high-performance systems already. They did it at Sun Microsystems, and they did it for Cray. So this is not the first bite of the apple for them. Here's where we are in development. We said we'd ship our first prototype system by the end of the year, and we did. The San Diego Supercomputer Center is up and running and getting very encouraging results out of it. We'll ship beta units later this summer, and we will introduce commercial units by the end of the year. We have 8 systems up and running in our labs. You know, the performance numbers that we talk about are absolutely repeatable. They happen in every one of our systems, and they happen all the time. And in addition to the performance numbers, we also talk about the ability to configure and reconfigure, never touch a cable. This is all 100% software-defined infrastructure. You want to move a group of compute off of one system onto another? No problem. Click, click. 2 clicks, 1 click to take it off of this system and add it onto that system. The business model is pretty simple, right? We're selling top-of-rack switches. We sell director-class switches. We sell cards that go into the servers and lots of software that connects it together and manages the fabric. The customer pipeline is deep. Mark, who is here, will talk to you in more detail. The important part on the chart is the variety of customers, right? And we purposefully tried to go cover a fairly wide base because we wanted to understand its validity. And it doesn't matter to us whether it's going to the cloud providers or to the enterprise providers, they have exactly the same problem. We're right now in the processes of raising a Series A of $5 million. We have just over $4 million of that is committed or in the bank. We're looking to close that out. The funding will help us get ourselves to that launch point, at which point we'll go off and raise the Series B. Yes, there are financials, and unless somebody wants to ask a lot of questions, I'm happy to go over it, right? The good part is, you know, it's a model which gets healthy fairly quickly, right? The margins are good in this business, and you know, it's a nice model. And so in summary, it's a big market, right? It's an $8 billion market remember, 91% of the customers are unhappy, and I can tell you from customer visits, I've yet to meet the 9 that are happy. It's growing about 15% a year. We got a great team to pull this off. We have great competitive advantage. Other technologies just simply can't do some of the things that we can do. And the patent position, you know, patents are a roadblock. They're not going to prevent you from getting there. So with that, we're Gigalo, and we're happy to take questions. Yes, sir. I'm sorry, you said the market? Oh, so the question was, what do you see the market for optical interconnects? For us, it doesn't matter, right? Because, you know, we're running the protocol on top of that connect, so whether it's copper or optical, we can run on either one, right? So obviously, you know, we see from people, if they're going to travel distance, they're going to go optical, but generally speaking, we hear an awful lot of the data centers in a rack, in 2 racks, 3 racks, they want to stay copper because it's cheap. Yes, ma'am. Thank you.
My question is, well, it's really impressive technology. Well, one missing part is, how do you think about the competitive landscape? Who do you compete with? And maybe there's so many, I started to hear more and more companies trying to get into the space. I wanted to also hear your mind. How do you compete with those emerging players?
So the question here was around competition. And the competitors are alternate technologies, right? So the largest network that's in use today is Ethernet. But as you can see, in these high-performance systems, they have a problem in terms of performance, right? Plain and simple. But they're still the widely most used. Second up is Mellanox, right, with InfiniBand, and our performance is just better. And so I think, you know, the question here will be, Mellanox is largely seen as a proprietary technology. You know, Ethernet is open. It's open and standard, but quite slow. Mellanox is a proprietary technology, seen that way. Cray has a proprietary interconnect. Intel brought out OmniPath, also seen as proprietary. We're 100% based on PCI standards. So we are, once again, an open standard, right, that we're 100% compliant to the standard. So I think ultimately the competition will shake out in terms of people are going to prefer open over proprietary, and there's really going to be only 2 open choices. There's going to be Ethernet, and there's going to be PCI Express. And if we keep running hard, we will dominate PCI Express. And Ethernet we're not going to replace Ethernet. We're a complement to Ethernet. All right, very good. Thank you.